Hi and welcome to video 2. This is the second of 3 videos for section 10.4. Video 1 we looked at the basic arithmetic, addition, subtraction, multiplication, scalar multiplication. In this video we're going to look at the properties of the addition and scalar multiplication, as well as how we can use that to solve matrix equations. So the properties of addition and multiplication of matrices is basically similar to what we do with real numbers. So let's start with the following. Let A, B, and C be M by n matrices, so they're all the same dimension, which we know we have to do in order for addition and or subtraction. And then let's let small c, so maybe I should change these numbers. Let's use, so ABC, let's use J and K be scalars. So the first property we have is that A plus B, so if we add matrix A to matrix B, it's the same as if we do B plus A. So just as if we're adding two numbers, 2 plus 3 is the same as 3 plus 2. The order doesn't matter, same with addition of matrices. Second, grouping. So if I have A plus B, if I add those together, and then add a third matrix C, it's the same as if I add the matrix A to B plus C. And realistically, we take this one step further, we could add A and C, and then add the matrix B. So it doesn't matter how we group them together, which one we add to which one first or second, we get the same answer. If I have J times K times a matrix A, this is the same as if I just multiply J and K and then multiply that times the matrix A. So whether I multiply by the scalar and then multiply by another scalar, or if I just multiply the scalars together and then multiply it by the matrix, I get the same answer. Number 4, if I add the scalars and then multiply it by the matrix, it's the same from a distribution standpoint as if I do J times the matrix A and then K times the matrix A and then add that result together. And lastly, if I have J multiplied by the sum of two matrices, again, from a distribution standpoint, it's the same as if I do J times A, and then do J times B, and then add the results together. As I said, pretty much similar to real numbers, it's just now we're having matrices that are involved as well. So those are our properties. The second part of this video is solving a matrix equation. So let's say I want to solve 2x minus a equals b for the matrix X. I don't know what that is, I'm trying to figure it out. If my A matrix is 2, 3, negative 5, 1, and B is 4, negative 1, 1, 3. So what I would suggest doing when you have this kind of problem, don't put the matrices in, solve this equation first as if it's a regular algebra problem, And then once you get x is equal to something, because we have all these properties that apply similar to real numbers, then we can put the matrices in at the end. So if I have 2x minus a is b, and I want to get x by itself, what do I have to do? I have to add a to both sides. So that means 2x is equal to a plus b. And now to get x by itself, I have to divide everything by 2, which is the same as multiplying by a half. So that means x is equal to 1/2 times a plus b. So again, that's essentially like this guy here, number 5. So we can add the matrices together and then multiply it by the scalar, or we could distribute the half to each piece. Whatever choice you choose is fine. But I'm going to add the matrices together first. So if I have 2 plus 4, that's 6. 3 minus 1 is 2. Negative 5 plus 1 is negative 4. And 1 plus 3 is positive 4. So now distribute this half to every entry. So 6 times a half, 3. 2 times a half, 1. Negative 4 times a half, negative 2. 4 times a half, positive 2. So that is the matrix X that if I was to plug it into this equation, given that A and B are these two matrices, will give me an equal answer at the end. So that's it for video 2. 1 and 2, not too long. Come on back, we're going to look at video 3. It's a little bit longer, but it flows pretty well. And again, I just leave it together so that if you have to look up these multiplication of matrices, it's all condensed into one video. So come on back and we'll take a look at that.